Assalamu alaikum.
Walaikum salam.
Okay, good morning. I
Thank
won't go into much discussions as we have to keep the lesson short today, but just one quick thing. How is your brother now?
My brother's going all right. His oxygen levels are depleting, which is good.
Okay.
He's recovering. Yeah.
And has he undergone the surgery?
No, they found a clot in his lungs,
Yes, yes.
like a fat clot
Mhm.
in his lungs, and they used the surgery time to take that out. They can't really take it out, but they had to thin it, which will take a couple days.
Inshallah, he will be all right. And was he driving or like was he on in a bus or something?
Oh, he was driving.
Okay, okay. Hmm. Wait, we should be very careful while driving. Was it in a
Yeah.
highway? I guess it's in a highway, right?
It was not.
It wasn't.
It was like an on a normal road.
Okay.
Mm.
Okay, whatever has happened. I hope he recovers real quick, real soon, inshallah. All right, so I won't ask how you've gone with the homeworks because I understand what you went through all these days.
Yeah.
Okay, but I guess up until number 10 it should be easy. So let's start from number 11. Okay, so we were doing this maths of surface area and volumes of three-dimensional objects. Okay, so let's see. Number 11, a cylindrical plastic vase is 66 centimeter high and has a radius of 12 centimeters. The center has been hollowed out so that there is a cylindrical space with a radius of 9 centimeter that goes to a depth of 48 centimeter and ends in the hemisphere. Okay. So now what do we have to do? We have to calculate the area of the external surfaces of the vase. What is the external surface? As you can see, the big cylinder here. Okay. And what is the formula? The formula is, if you would remember, it is
Oh, for
2
area
pi r,
surfaces?
sorry, not 2 pi r h actually. I mean the two surfaces. Okay. So two surfaces are pi
Yeah,
r square plus pi r square. Okay. And for
yeah.
the um, uh,
Fire H.
yes, pi r h, yes, pi r h plus pi r h. That is the like curved surface. Okay. So altogether we had the formula to be 2 pi r into r plus h. So this is the formula you would use to calculate for 11a. And the internal surface, in case of internal surface, we have a cylinder, the radius of which is given, the height is also given. And for the hemisphere, the formula is 4 pi r squared. It is for the sphere, and for a hemisphere, we will divide it by 2. And what is the radius of the hemisphere? It's 9. So you will replace r with 9. Okay. And you will get the answer. Now, next up, the top of a church tower is in the shape of a square pyramid that sits on top of a rectangular prism base that is 1.1 meter high. The pyramid is 6 meter high with a base length of 4.2 meter. Okay. So what do we have to do? Calculate the total external surface area of the top of the church tower if the base of the prism forms the ceiling of a what? The base of the prism forms the ceiling of a balloon. Okay. All right. So whatever it is said here, see for instance, first of all, that is we have four of these rectangles, right?
Yes.
We have four of these rectangles. So their surface area would be 4.2 multiplied by 1.1 times 4. Okay. So you've got the surface area for these four rectangles. Okay.
Yes.
Right. Now they have said the external surface area, right? The external surface area. So that means the base of the pyramid, we don't have to calculate it. Okay. That is not needed here. All right. So now we have to calculate the surface area of one of these triangles. We have to calculate the surface area for one of these triangles, and we will be okay with it. Okay, all right. So now are the triangles equilateral? Let me see that the rubber term. Okay, so understand one thing. If it is a square pyramid, listen very carefully. Yeah. See, if it is a square pyramid, okay, right, and this is the center point. Okay, I can't like draw it in a
Okay.
traditional way. Okay, so this is the top. Okay, now if I join the four of the corner points from this top point, won't they be same? The answer is yes. Okay,
Yes.
the triangles are equilateral. That means that both of these two sides will be equal. Okay, both of these two sides would be equal. All right. And another thing I just understood that it won't be needed as well, but it is an important information to know because the height of each triangle is given, and what is the base? The base is 4.2. All right. So for the triangle, it would be half times 4.2, which is the base times the height is 6, and we have four these triangles. Okay. So adding them together, you will get the total external surface area. Okay.
Okay.
It's a lot easier than like calculating volumes. Okay. Okay, a dumbbell consists of a cylindrical tube that is 28 centimeter long with a diameter of 3 centimeters and two pairs of cylindrical discs that are held in place by two locks. Okay. The larger discs have a diameter of 12 centimeter and a width of 2 centimeter. Fine, and a smaller discs are the same thickness with a diameter of 9 centimeter. Correct. Calculate the total area of exposed surfaces of the discs when they are held in position as shown in the diagram. All right. So one thing I need to understand. Do I need to calculate it like okay, just a second. A dumbbell cylindrical diameter. Okay, fine. That means I have to calculate. I mean, we have to calculate the surface area for cylinders. Okay, although this for simplification this diagram is showing like rectangular things, but it is not a rectangle. Okay, so we have to
Okay.
calculate in a cylindrical way. So first of all, 28 centimeters long, all right, that is okay, I understand that, and with a diameter of 3 centimeters, all right, the diameter of 3 centimeter. So that means the total area for this cylinder, and this cylinder would be 2 pi into 3 upon 2 times 3 upon 2 plus 28. This will be in centimeter squared. Okay. All right. So we have got the area for the steel rod. Okay. All right. Now what is the like area for the discs? Okay. So the discs are also cylindrical. Okay. So larger discs have a diameter of 12 centimeter and a width of 2 centimeter, and the smaller discs are the same thickness with a diameter of 9 centimeter. Now, what you have to understand here is, see, this is a cylinder. Okay, so cylinders, what they are saying is thickness. Okay, now consider this cylinder. Okay, consider a big cylinder. Okay. So, if you consider this portion, we are considering it height. Okay, now here you might be asking that they are saying the width. So, how do we calculate it, right? That might be a question.
Hmm.
So, the thing here is, as you can see, that the diameter is given, which is 12 centimeters. So how can I explain this thing actually? A smaller discs have the same thickness and with a diameter of 9 centimeters. Okay, see. So the diameter, obviously it would be turned into radius by dividing it into 2. I mean, dividing it by 2. So 12 by 2 for the first one, 2 pi. And the other thing that is needed is the height. Okay, that is the height. Now, see, this is the width that they're saying, right? I mean, consider this cylinder. Okay. What is the height of this cylinder? Okay, tell me.
Very short.
Very short, right? This is very short. Now the question setter has tried to be like very witty to confuse the students by saying terming it with width, but actually it is also the height of that particular disk. It is also the height of that particular disk if we consider that disk to be cylindrical. Okay. All right. Understand my point? Because
Yes.
usually disks are not cylindrical, they are like a circular thing and we consider them to be 2D. Have you used compact disks or CDs anytime?
This.
It was available when we were young, but
Mm,
it's obsolete now, almost obsolete actually. All
mm,
right. So I mean, here the width means the height. That is what my point is. Okay. So as it is a very short height, you might get confused that okay, so width maybe width. Where do I get the height? But actually, it represents the height. Okay, as you could understand from the diagram. All right. So now what do we do? What we do is 12 upon 2 times the width is 2 centimeters. So width means height. So that is times r plus h, that is 12 upon 2 plus 2. Okay. So that is for the bigger circular disc. Okay. And for the smaller circular disc, we will have 2 pi times 9 by 2 times 9 by 2 plus 2. Okay. And we have to do a last thing that the smaller discs should be multiplied by 2, the bigger disc area should be multiplied by 2, and the cylinder multiplied by 1, and add all of them together to get the total surface area. Okay.
mm.
I think this is a particularly very important thing because of like practical knowledge oriented question. Okay. So very good question.
Um, don't you have to minus the big discs by okay, so like because they're like so close together, they're touching the some of the exposed surface of the um disc
Mhm.
is minused by the smaller one.
I understand your point. Very good question, but I don't think like that is part of our consideration because if we are to calculate that particular surface area, which is like covered by the like bigger surface, okay, so I we don't have that particular information or enough information to calculate that. Okay, so this sort of
Okay.
area we cannot be calculating it. Okay, and the exposed surface, what think it in another way. That is like separate all of the like dumbbells and then calculate the surface areas together. So that means that all of them are exposed surfaces, right? Okay. So I think it should be like that. Okay. But if you find like after calculating that the answers do not match, obviously let me know. But I don't think it's necessary that we have to like calculate that. Okay. Right.
Okay.
And okay, again, let me tell you one thing. Even if we have to like calculate that, what should we have to do? Okay, so see, like the one thing that is being calculated twice is the smaller dumbbells pi r square, right? Smaller dumbbells, 1 pi r square, not even 2 pi r squares. Do you understand? Like this top
Yes.
surface, this is the pi r square, right? This is the pi r square. Not the bottom surface, just the top surface. That is what it is matching with. Okay. And in the other side, there is a pi r square as well. What is the value of r? The value of r is 9 upon 2. Okay. All right. So that is the thing. Now, if you debate on that, then I will come up with another argument, that is, see, this is the whole cylindrical rod. Now, some portion of the cylindrical rod is like covered by the dumbbell's width as well, right? Is that correct?
True.
So
True.
should that be deducted from the cylindrical rod, like 2, 2, 2, 2? So the height of the cylinder in that case shouldn't it be like 20? Okay, if you consider it like that. Okay, all right.
Yeah.
So I don't think you have to think that much critically. I don't think so. Okay, if you find like any sort of discrepancies after like doing all these, like the answer does not match, then let me know. So then we might think about that. Okay, but at your level, I don't think so. It shouldn't be like that. Okay. All right, but
Mm.
even if you have to think it like that, I have already said what the yes you have to follow. So I hope you will be able to.
Okay.
Okay. A staircase is a section of red carpet down its center strip. Each of the 9 steps is 16 centimeter high, 25 centimeter deep, and 120 centimeter wide. Okay, the red carpet is 80 centimeter wide and extends from the back of the uppermost step to a point of 65 centimeter beyond the base of the lower step. Okay, determine the area of the red carpet. All right. So, first of all, what you have to, and these are like very long. Okay. See, so for the area calculation, few particular things. First of all, in this we call it a step. Okay, in this step, let me draw. Okay, so the area of this portion is called the step. Okay, so the area of step has to be calculated. Okay, and this is the riser. Okay, so there is a particular area for riser as well. As you can understand that for the riser portion you have the, well, you have to calculate the area as well. Now as you can see, they have already mentioned that the red carpet is 80 centimeter wide. Okay, so that is 80 centimeters. Okay, and the what is the height of the riser? Height is 16 centimeter. So for these rectangles, the areas will be 80 times 16. Is it understandable?
Yes.
Centimeter squared. Now, as since high, okay, all right. Now, the red carpet is 80 centimeter wide. Okay, 1 second. What does it mean by 25 centimeter deep? I think by deep, what they mean is like this bit. Okay, like this portion. Okay, this is what deep means. All right, understand the point? That is what
Yeah.
deep means. All right. Now, so for these portions, like this one, all right, in the upper portion, this one, we draw it with another color. So it will be 25 centimeter deep and the red carpet is 80 centimeter wide, so centimeter square. Okay, fine. So far, so good. There is no difficulty up until now. All right. Now, the problem is that there are like 9 stairs. Okay. So that means these will be multiplied by 9 and these will be multiplied by 9 as well. Okay. All right. So the last thing we need to do is that is the thing that the, I mean, the red carpet is 80 centimeter wide and extends from the back of the uppermost step. Back of the uppermost step. Okay. So should the uppermost step be counted? 1, 2, 3, 4, 5, 6, 7, 8, 9? No. So uppermost steps like this green portion won't be counted. So for green, we have to multiply by 8. Okay, understanding my point? Like,
Yes.
okay. But for like risers, all of the 9 stairs would be counted, multiply by 9. Okay, so far so good. All right. Let me write it with yellow. Just a second. 9. All right. Now, to a point 65 centimeters beyond the base of the lower step. So this particular value is 65 centimeters. This is 65. Okay. Now you have to separately calculate another area, which is 65 times 8 centimeter square. So all of them added together will give you the total surface. Tell me, it's a like formula wise, like you don't have to memorize any formula or something, but like conceptually, you have to be very careful, like where you have to multiply by 9, where with 8, and lastly, you have to like multiply with 65 and 80. Okay, so you have to be very careful about that. Understand?
Okay. Yeah.
If all areas of the front and top of the stairs that are not covered by the red carpet are to be painted white, what is the area to be painted? Okay, this is very easy. Like you have to calculate the area of the stairs. Like in the way you calculate the area of red carpet, you should calculate the area of the stairs and just like subtract the values. Okay, nothing new here. All right.
Yes.
Okay. Okay, it's already like 7:13. How much time do we have?
Um, I'll be on the bus by 7:45. Takes around 5 minutes to
Uh,
get there.
how many?
25 minutes,
No, I
you can
mean,
say.
how
Oh,
much walk do you have to take the bus? Actually, that is what I'm asking.
it's around 5 minutes.
Okay, so that's okay. So 7:30, we should be able to continue to 7:30, right?
Yes. Yes.
A rectangular swimming pool is 12.5 meters long, 4.6 meter wide, and 1.5 meter deep. If all it was okay. So very easy formula. What was the formula? 2 into AB plus BC plus C. Okay. Just plug in the values. Okay, so it will be 2 into 12.5 times 4.3 plus, let me give you a second bracket, plus 4.3 times 1.5 plus 1.5 times 12.5. All right, so you will get the answer, right? A quarter pipe skateboard ramp has a curved surface that is 1/4 of a cylinder with a radius of 1.5 meter. If the surface of the ramp is 2.4 meter wide, calculate the total surface area of the front, back, and sides. Okay. Okay. So we have already got the uh, values, that is the radius is 1.5 meter and we have to calculate a particular surface area for a cylinder. Okay, very good. Now, how do we calculate like for front, back, and sides? So for the sides, what we have to do is calculate the pi r squared. Okay, pi r squared. Okay, and for the front and the back, you have to calculate the curvilinear surface area, which is pi rh. Okay, pi rh. And again, which is misleading, is 2.4 meter wide. That will be our height. Okay,
Okay.
so just plug in the values and you will get the answer. All right. Okay. And again, I will say like whenever you get time, practice these maths because otherwise you might forget them. Okay, and try to prepare on
Okay.
time. And also there the answers are also given. Okay, so it will be like easier for you to justify if you are doing correct, or if you can let me know if I have solved anything like in an incorrect way. I hope not. All right.
Yeah, I hope not either.
So now, as you said that we should be focusing on permutations and combinations. Okay. And you also have like binomial expansion, Pascal's triangle, etc., etc. Right?
I know Pascal's triangle.
Okay, you know Pascal's
Yeah,
triangle. All right. So Pascal's triangle is actually really easy. So what you have to
it
do is
is. It is.
see, firstly, if you remember the formula for a square plus twice ab plus b squared. Okay. So what are the coefficient of the terms? For a square, it is 1. For 2ab, it is 2. And then for b square, it is 1. All right. So these are the coefficients. Okay, very good. Now, in that way, we can continue. Like in the leftmost and rightmost side, we will have 1. And the middle terms would be addition of the upper floors or like upper steps, whatever you want to. A3, sorry, 1, 3, 3, 1. Then 1, 4, 6, 4, 1. Then 1, 5, 10, 10, 5, 1. 2, 3, 4, 5, 6. Okay, yes. All right. So in this way, you can keep on continuing like that, like. Okay. So why is it significant? It is significant because we cannot be like memorizing all the formulas for uh, like various exponents. Like if the exponents are very high, then it is very difficult for us to like remember all the formulas. Okay. So that is why we can use this thing to calculate the coefficients. Okay. And later you will know that you don't even have to memorize these Pascal triangles. You just have to get the idea of factorials and you should be able to solve
And NCR.
NCR, right? NCR. All right. Okay. So have you studied about NCR and NPR?
A bit. Yeah.
All right. We will discuss about them. No worries. So before that, what is factorial? Factorial means that if you have any sort of positive integer, okay, actually there you might find some articles online that you can do factorials for fractions as well and something blah blah. But I don't think that will be studied at your level. Okay, so let us consider for factorials that we have to have positive integers. Okay, so say for instance, what is 7 factorial? So what we will do is we will multiply various numbers. Okay, we will start from 7 and it will keep on decreasing. So 7 multiplied by 6 multiplied by 5 multiplied by 4 times 3 times 2 times 1. Okay, and it ends. So from that particular number to number 1. That is how we will continue. Okay. In case of 5 factorial, what we will do is 5 times 4 times 3 times 2 times 1. Okay. So I think you know these things, right? So
Yes.
what it means is if we are going to find in factorial, there's a very interesting thing. It will be n times n minus 1 factor. Now, why did I say that? See, very easy. See, for instance, if I write 5 factorial equals to 5 times 4 factorial, does it satisfy this equation? Tell me.
Yes.
Because 4
Yes, it
factorial
does.
will be 4 times 3 times 2 times 1. Okay. Now, from this particular formula, you will get a very important idea about factorials. That is, obviously, you can understand that 1 factorial equals to 1. Okay, very good. What, what is 0 factorial? How can you get the value for 0 factorial? Tell me.
Um, 0 factorial is okay. Let's just say the n factorial is 0 factorial,
Mhm.
and if you substitute,
You will get a minus 1 and you cannot factorize any negative integer. Okay,
yeah, that makes
in case
sense.
like making factorials. Okay. Okay, so you are very close to getting the answer. The answer is very simple. Just consider the value of n to be 1, not 0. Okay, so what do we get? So in that case, what we get is 1 factorial equals to 1 times 1 minus 1 factorial, right? All right. Now that means that 1 factorial is equals to 0 factorial, or you could say 0 factorial equals to 1. Okay, this is a very important thing. You would get like short questions you might be asked in the Viva board as well to begin with or warm you up, like what is the value for 0? Okay. All right. Now let's see. Should I go to binomial expansion first, or should I go to like factorials and then maybe permutations and combinations? What
Good
should we do?
choice.
Okay, let me check your syllabus first. Then it was in specialist mathematics, right? Let me real quick.
Yes.
What is the chapter number?
I think it's 1.
Chapter 1. Okay, so course content, right? Where is it? Am I on the right book?
Uh, you're on 4.4.
Yes, I'm in.
Oh, you're in a different form. Okay. Go back to my bookshelf
Okay, my bookshelf.
and go on to there should be like 3 paper stacks symbol on the bottom left-hand corner of the math specialist one.
This one?
Yes.
Okay, select format. Which one?
I think it would be ebook plus. Open in ebook plus.
Okay, open an ebook plus. I can download the PDF as well.
I haven't tried that.
Okay, I think okay, I'll check that. Okay, all right. In chapter 1, then factorials and permutations. Okay, factorials, permutations. Okay, all right. I don't think in this chapter you are studying binomial expansions, but I think binomial expansions are part of your study. All right.
Yes.
All right. Okay. So I think, okay, let's start with factorials. In case of like permutations or combination, let's, as we have like very short time, say what is permutation and what is combination? Okay. So for instance, say for instance, you are here in Sydney. Okay. You are here in Sydney. And there is Melbourne. Okay. And there is like, say for instance, what Perth. Okay. So now there is no way that you could go to Perth directly. Okay. So there are 3 ways to get to Melbourne. So you could go by bus, you could go by air, or you could go by train or subway. Okay.
Mhm.
From Melbourne to Perth, you could go in 2 ways, that is bus and air. Okay. Now, what permutation implies is that what is the total number of ways you could, okay, we will calculate that much. Okay. Say for instance, what can you do? You could either go bus and then take another bus. That could be a way. You could take air and then go via bus. That is another way. You could take train and then take a bus. That is another way. All right. Then again,
All
you
right.
could take bus and then sorry, what did I sorry? Yes, bus and then air, and then air and then air, and then train and air. See, here we have calculated the number of ways possible to go in Perth. Okay. In like various doing some various combination and permutations and like that. Okay. Now there are like various sort of practical life examples. Say for instance, if I give you like you went to the cricket World Cup match. Now in a cricket World Cup, say there is a group of 6 teams. There is a group of 6 teams. 1, 2, 3, 1, 2, 3, 4, 5, 6. 6 teams. Now if we are to like find how many matches will be played, what should we do? right? What should we do? That is our question. So, like, each of the teams will play how many matches? Tell me.
6.
No, 5 matches. They cannot play
Oh,
matches themselves, right?
that's true.
Correct. So that means all of them would play 6 matches. Okay, sorry, 5 matches. Okay. Now think in this way, like New Zealand plays 5 matches, Australia plays say 5 matches, Bangladesh plays 5 matches, India plays 5 matches, Pakistan plays 5 matches, and England plays 5 matches, right? So now in that way, we are thinking that okay, there should be a total number of 30 matches in this group, right?
Yes.
No, actually not, because in one particular match, we will have two teams playing together, right? So that means in
Mm.
this case, what is the permutation? That will be 6 times 5 upon 2. Okay. So I'm like saying sort of like things like how permutations and combinations and are relevant to us. Why should we use them? Okay. I can say, for instance, you have three, say, what do we call, three rings? Okay, three rings. Okay. So now, how many ways can you like order them or arrange them in your 5 fingers? Now, how many things do you have to consider? Okay, so you have to consider first that I can wear three rings in each of our fingers, right? Like I can put three rings on my like thumb. I can put three rings on my index. I can put three rings on my like middle finger or like ring finger, and so on, so on. Okay, so that is the one thing. Then I have to consider like how can I put two rings in one finger and one ring in another, and then three rings separately. So what I have just tried to do for today is just give you a brief introduction that how permutations and combinations are relevant, because we didn't have that much of time, and it will take several classes to understand this thing. But if you understand this thing properly, I am pretty sure that uh, you will find maths attractive as much as you find attractive chemistry. Okay, that is like I'm pretty sure about that, because everything's practical here. Okay, no memorizing, no nothing. Okay, but you have to be very careful while reading the question. Okay, because the understanding the language of the question gets very difficult in permutation and combination. All right, so we will discuss in detail about permutations and combinations in the next day. Just tell me, are you free tomorrow?
Um, Tomorrow, I'm not sure. I'll say yes,
Mhm.
and we can do that at uh 5 o'clock my time.
5 o'clock your time. That means 7th of November, 1 p.m., right? Is it correct?
Yes.
All right. Is it possible to make it 12?
Mm, yes.
Okay, 12.
We can
And
try.
okay, because why I'm willing it to make it 12, if it's possible, then if we can continue it to like 2 classes, that would be better as well. Okay. But for the
Okay.
timing, let's consider just 12. Okay. If not possible, then 1 class. Okay. All right. So what was I saying? Okay. 7th November, 1/5 p.m. Okay. All right. See you then. Okay. Allah Hafiz.
Yeah, I love this.